How's it going, everyone? Stefan here. Today we're going to be talking about column qualification, specifically phase transition analysis. And I hope to touch on, I guess, the backgrounds of what's going on with this kind of column qualification analysis and maybe give you a few reasons why you might use it and then show you how one way that you can do the analysis. So let's get started. I have two ideal functions here. First, the step function that I'm calling S of t, and the pulse function that I'm calling P of t. Starting with the step function, you can see that we are starting at some value, probably 0. It's flat, 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 until you hit a time. I'm calling it t star. When you go in a straight line up to maybe a new signal, call it 1, and then you continue on flat. The pulse function, P of t, is just the derivative of S of t. And we'll see that makes sense here in a second. So the pulse function, you're going to be at 0, 0, 0, 0, 0, 0, until you hit time is equal to t star. And then your signal, your P of t, will go up to infinity and then back down and continue at 0. That makes sense, right? If we look back at the step function, when we're flat until time t star, and then we go up in a straight line, so that slope is infinity. So it makes sense that at time equal t star in the pulse function, our signal is going to go up to infinity. Now, how does this actually relate to column qualification? Well, let's see. So you may actually see something that, plots that look like this when doing qualification or just running a chromatography step. So I guess we'll start over here. This would be your pulse function, right? This is what your chromatogram might look like when you do, pulse qualification, where you inject a slug of some signal buffer. Maybe it's 2 molar sodium chloride or something that has like 1% acetone in it, and you get a nice Gaussian peak. It looks a lot better than what I drew there. Yeah, so this is pretty standard. I think anyone that's packed columns before has seen this. But if you're running chromatography, you've also seen something like this. On the left, our phase transition plot. This might show up in your chromatograms if you're going from a low salt buffer to a high salt buffer. You see that kind of step change there. And yeah, as we saw above, what you can do is you can just take the derivative of this function and you'll get a curve that looks like the pulse function. Yeah, it's really that easy. So when I first was doing the phase transition analysis, I didn't know that you can take a derivative of your line and unicorn. And if you didn't know that, you can do that. At least you couldn't in the old versions. I don't know about the new version. But anyways, yeah, I mean, you can just take the step function, take the derivative of it, and then you'll get something that looks like a Gaussian peak. Yeah, and then from this, this function, of course, unicorn just does this for us, but we have our, this would be max peak height. We'll call it 100. And then this would be 0. And then somewhere there's a 10% max peak height. 10% of the max peak height. And then it finds the width of the curve, or of the curve there. And that's how they calculate the asymmetry. So that's why you may see this called like asymmetry 10%, because it's at 10% of the peak height. Yeah, it's just the ratio of those two distances. We can call the middle of the peak here VR, or like the retention volume. and then we can calculate the number of plates. This is just an empirical formula, which would be 5.54 times the retention, or times the retention volume over WH squared, where WH is, so like if this is 50, it's like the width at half the peak height. Yeah, WH. And then the last thing that you probably see if you're packing columns is the HETP, which is just the height of your bed, your bed height, divided by the number of plates. Um, at least this is how I remember these calculations are. You don't really need to know these. Unicorn's just going to do that for you. But if you're like me, when I started out doing the phase transition analysis, I didn't know that Unicorn could take the derivative, so I was doing it in Excel. I was exporting the data and doing it in Excel. So I did use these formulas at one point. And if you're going to use these, I would just double check that I've reported them accurately here. And before we move on, I'll note that the number of plates is actually like has to do with like the moment of this function, of this like Gaussian function, or Gaussian curve. I don't know what the formula for the moments are, but you could look into that. There's like the first moment, second moment, third moment, and so on. And that's another way to calculate the number of plates, probably more accurately. But I haven't seen anything about moments since I was in calculus class. So the next thing I want to talk about is like when you may actually use this. Well, one thing is if a pulse injection or like a slug injection is not possible. That's when I first used phase transition analysis. I was packing and qualifying a BPG, like a 2-liter BPG column, and I was using an active pilot, and there was no way to there was no sample loop, there was no injection method. I guess I could have used like the B line really quick, but those valve changes on the old active pilot, you may know, kind of slow. I don't know how good of a job it would have done with the injection. So the phase transition analysis was used. The other thing that you may use this for um, would be like you'll notice I'll go up here, like you see this in your chromatogram potentially as you're like changing phases. So one thing is like whoa, I don't know what that is. Let me get this out of here. Okay. You don't no need, say no need for a dedicated qualification. If you're just checking, like obviously after you pack, you're going to have a dedicated qualification, but if you're just trying to track how your columns, performances over time, you can just pull this out of your chromatograms and do the phase transition analysis. Yeah, I'll just leave it at those two. I think those are two reasons, to do this. There's probably more. If you can think of any, drop them in the comments. So the last thing we'll go over today is how do you do this analysis in Excel? Because that's how I first did it. So I'm just going to share my screen to Excel. And okay, so here we have a step function or like a phase transition. Maybe you're going from a I don't know, this isn't maybe let's say this is at the end of your run and you have your elution buffer with some low level of salt, and then you're doing a strip, a 2 molar. I don't know if you'd actually want to do it where you have potentially have other species eluding. So maybe we say this is at the beginning of your run. You're going from some low salt buffer into a higher salt buffer. And that's your phase transition. Well, you can just take the derivative, which I've done over here. You'll see that I am not taking, so the derivative is just the slope, right? So I'm spreading this out by like um, 4 points here, and that's just to try and smooth things out, kind of average things out a little bit. You could do it every one, you could do more. If you're pulling this from Unicorn, you probably can do a lot more because their data acquisition rate can be high if you select that. But anyways, I just have the slope here calculated over 4 points, and then you got a little preview of this. This is the output. You can see where this is going, a pulse function uh, from the phase transition. Obviously, this peak is really ugly, but that's just because I was entering in random numbers to try and get a nice step function. And then here it would be pretty simple to, find 10% of the max peak height, find 50%, find the width, um, find that A and B. So you can do all of that pretty simply here in Excel. I'm not going to go over that. I'll let you figure it out. But if anyone has any questions on how to do that, I can explain in the comments or make another video on how you would actually calculate asymmetry and the number of plates using those formulas I showed in Excel. I hope this was helpful. I hope I did phase transition analysis some justice because it's pretty useful, and I I really like it. So yeah, hope you enjoyed the video and that it was helpful for you the next time you have to pack and qualify columns. Thanks.